It happens quite often when you get to a calculus class that we ask you, what is the sine of pi over 2? Or what is the tangent of 3 pi over 2? Those are things that we ask quite a lot. And we want those to happen, quicker rather than slower. And here's the idea. Notice these angles that you're given. They're all on the axis, aren't they? So 0 has what for a terminal point? What is the terminal point at 0? 1, 0?
Yeah.
What's the terminal point at 90?
0, 1.
0, 1. Terminal point over at pi?
-1, 0.
-1, 0. And 3 pi over 2 is 0, -1. And 2 pi is all the way around back at 1, 0. So as you work to fill out this chart, notice that the sine of 0, sine is just the y value. So the sine of 0 is 0. Whereas the sine of pi over 2 is the y value of 1. As you change it, cosine of 0 is 1, whereas the cosine of pi over 2 is 0. See the difference there? So it's very common for me to say, okay, you guys, what's the cosine of pi? And I'll get answers from my calculus class. Some will say 0, some will say 1, and some will say -1. Everybody get why people might shout out those answers? When you think cosine, you're thinking x value over there. The x value is -1, and that's what you want to come up with, okay? So go ahead and take a minute or two and try to float through that chart a little bit, okay? Go ahead. Yo.
I won't be here tomorrow.
We're gonna miss you.
So when can I meet you? Just in call.
Sounds great. Okay, something else I'd like to show you. We talked about tangent. Tangent of theta is equal to y divided by x, which people said that's the same thing as slope, right? Well, notice if it's 0, I think, what is the tangent of 0? What's the slope of the line like that? Slope of a horizontal line is? 0. Okay, suppose it was pi over 2. What's the slope of a vertical line? Undefined. Pi. Slope of a horizontal line? 0. 3 pi over 2. Slope of a vertical line? Undefined. And then, so I just think, I think of that picture in my mind every time. I don't always go through the process of y divided by x. Okay? And those are things to consider. So what we want you to be able to work through eventually is be able to, as it says, determine the exact value of the following trigonometric functions. If possible, try to visualize the unit circle as opposed to drawing it out. So we are going to draw it out because that's the only way I can teach it. I can't teach it if we're sitting here visualizing it. So we are going to draw it out. But if you can, it would be great if this could kind of happen for you mentally. So I look at the tangent of 3 pi over 4, okay? Some people may say we didn't do examples like that yesterday. Yeah, we did. We did 4 of them. It was just instead of asking you to find all 6, I'm now just asking you to find one of them. That's all we're asking you is just one of those values. Tangent of 3 pi over 4. So 3 pi over 4 is how many degrees? 135. What's the special triangle over 135? 45, 45, 90. Everybody got that? So if it's 45, 45, 90, it's going to be the root of 2 over 2 and the root of 2 over 2. You divide those, you're going to get? You're going to get a negative 1. So I know the value is negative 1. Now again, what did we do? We said, hey, it's 135 degrees. That's the first conversion. We know that well. We've been practicing that. And now that I know it's 135 degrees, I know I have a 45, 45, 90 triangle. And you've practiced this enough that you know the terminal point is negative root of 2 over 2 and positive root of 2 over 2. And a lot of that stuff people can start to visualize. And they can see that the tangent of 3 pi over 4 is negative 1. So it doesn't always end up having to be as large of a process. You can start by kind of seeing those things that you develop. Look at the one below it. We got cosecant of pi over 6. Well, I'm just going to start by using pi over 6. Pi over 6 is how many degrees? 30 degrees. So you have a 30-degree angle. That means that coordinate is what? What's that terminal point? Root 3 over 2 and 1 over 2. Now, cosecant I don't know much about, but I do know that it's the reciprocal of sine. Sine is which value? The x value or the y value? The y value. So the sine of pi over 6 is 1/2. So therefore cosecant is the reciprocal. Cosecant is 2. I'm going to give you guys a couple minutes to try a couple of those problems. Come on, I'll come around and check, see where you're at, but you can try each one of those, okay? Don't want to type in your calculator, you want to try each one, okay? If you need to draw the picture, go through the work as much as you can. Try to mentally visualize the rotation. Try to visualize the location, the unit circle. So for people who say like you get to 20, 20 is a great example of you think of 3 pi over 2 is right down here, right? So the first thing I'm thinking is that the location is 0, -1. Secant is the reciprocal of cosine. Is cosine the x or the y value? X. So the cosine is 0. What's the reciprocal of 0? Undefined. So you're able to access those values rather quickly. Okay. Take out your calculator. Take out your calculator. Okay. And when you get into your calculator, press mode. 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 Your calculator has different operations. It has radians or it has degrees. And this is something that you need to get used to navigating back and forth between. For all of trigonometry, you'll kind of be going back and forth. You need to get used to that. And on the test, one of the common questions they get asked is, Mr. Gens, should I be working radians or degrees right now? And my answer is that's something that you're expected to know. So I'm going to show you how you know whether or not you're working radians or degrees, okay? So right now, I'm going to move down. I'm going to move over to degrees. Most of the graphing calculators are set to default to radians. So make sure you're in degrees. Okay. So the first thing I'm going to find is the sine of 30 degrees. Okay. And if I think about a 30-degree angle, I know that the terminal point is the root of 3 over 2 and 1/2. So therefore, this should produce 1/2 or the y value. I press enter, and it sure enough does. Okay. But notice that that's a value we could have figured out on our own. Suppose that it's a value that we don't know, say the sine of 36. I don't know the sine of 36. 36 is not a special angle within a triangle. And so I press enter. Your calculator actually has this remarkable formula that is developed through Calculus 2 that it uses to try to come up with that value. Okay, so we get 0.5877, so on and so forth. Okay. Now, suppose I switch this and instead of degrees, I worked in radians. Press mode and then move down to radians. And now, if I press sine of 30, we all know that the sine of 30 degrees is 0.5, but if I press sine of 30, I don't come up with 0.5, do I? So this is clearly wrong. Whereas 30 is the same as what in radians? So if I type in pi over 6, I do get that 0.5 value. So notice sine of 30 in degrees gives you 0.5, and sine of pi over 6 in radians gives you 0.5. Everybody clear? Okay, so as we go to your this part of your assignment, it says use a calculator to determine the exact value of the following. I have sine of 46. Is this a degree or is it a radian? It's a degree. It has a symbol by it. I simply just go to my calculator. I'm in mode, and I change my mode to degrees. And I press the sine of 46. And I press enter. I get 0.7193. For trig values, you like to go to 4 decimal places, 0.7193. Now, the directions are incorrect. It says use a calculator to determine the exact value. We are not determining an exact value. We're determining an approximate value. Okay? If it says determine approximate, that's where you can use a calculator. But to be clear, on this section, you don't use a calculator. Okay? If you typed in sine of 5 pi over 4 on your calculator, you get negative 0.7071. And for that, I will give you 0 points on the test. Because in this section, you need to make sure you don't list negative 0.7071. You need to make sure that you list negative root of 2 over 2. So you have to actually do the trigonometry here, whereas here you can type in your calculator. Everybody see the difference? What's different about 24? Is that a radian or a degree? It's a radian. So I go back to my calculator. And I switch my mode to radian, and I press cosine, and I do pi divided by 9, and I get 0.9396. We'll do one more together. I want to look at problem number 30. 30, is that a radian or a degree?
radian? There's no degree sign.
It doesn't have a degree sign.
There's no degree symbol, so it must be a radian. Let's all agree that this kind of looks like negative 156 degrees, right? But if you don't see a degree symbol, then it must be a radian, okay? So that's the difference. This is a degree, obviously. This is a radian, obviously. This is a degree. This is a radian. This is a radian. So we're going to make sure that we're working in radians on your calculator. So go to mode, and I go down to radians. Good. I'm sitting in radians. And now I notice that I have sine, I have cosine, I have tangent, but I don't have a button for cotangent. So the way that you type that in is cotangent is the reciprocal of tangent. So we type in 1 divided by the tangent of negative 156. So anytime you get secant, cosecant, cotangent, you have to do 1 divided by. So grab that 1 divided by the tangent of negative 156 radians, and I get 0.5348.
Do you not want us to round that?
It doesn't matter.
Okay.
Okay, I'll give you a minute to kind of work through some of those. Then we're going to move to your new learning day. It's nice and short. Tomorrow is also a short lesson. We are scheduled to test next week, Friday. Friday.
Me and Ty won't be here tomorrow, right?
Yeah.
Is there any new materials or anything?
You'll be with Gina. Gina's not going to be here tomorrow either.
I will not be with Jenna.
Okay. Gina.
No.
It's Gina. People have gotten her name wrong for 12 years of schooling since preschool. I'm the first one to figure it out. It's not Jenna, it's Gina.
Yeah.
No new materials. This one?
No.
Oh, you're looking for what are
Yeah.
reciprocals of each other. I got it. Yep, I got it. My youngest developed an injury in cross country this year. Hip hurt, had to stop running. Eventually had to get it x-rayed. MRI, went on crutches for 4 weeks. Has been in physical therapy for over a month. And yesterday, not doing any sports yet, yesterday it hurt so bad she could hardly walk up. Like, we literally don't know when or if she'll ever compete again. We don't know. She's a 3-sport athlete. And she doesn't know. They're wondering if she has, apparently you have 3 growth points in your hip. And they've seen where some kids get like inflammation in the growth plate. They don't know if that's it. I can't figure out what's going on. But she was just about in tears just walking yesterday. She's not even playing a sport, so trying to figure out what the heck. Yep. So she missed half of her cross country season. They went to state. She was hoping she was gonna make the varsity team this year. She missed half her season. She was injured. They went to state. Wanted to play basketball. She's been the manager the whole time. And now track's coming up. She can't wait for track. Injuries are hard.
Is she the one that wouldn't wear her crutches?
Yep,
That
that was
wouldn't use her crutches?
yep, and she I mean we made her and she did. And after she got off the crutches, she was fine. But since they've been trying to work through it more with physical therapy and stuff, it just hurts.
Can it be a phone number?
Yeah.
So that's fine.
I got a running question for you, right?
Yeah.
So for our fantasy football punishment, Liam Ball has to run a mile,
Okay.
but at every quarter mile, he has to drink milk.
How much milk?
I don't know,
Work.
a good enough amount. The goal is not to lose fantasy football. so he's probably going to be throwing up. Connor Persig wants to know if there should be a minimum amount of time that he has to run this mile. Like a this is the cutoff.
Okay. Fully respect your ideas. Without a doubt, this is and when I was your age, I'd be right at that same spot. But now I'm older, and like it or not, something does happen as you get older. You get wiser. So there's actually a maximum amount of milk intake. So believe it or not, people have died from the gallon challenge in milk.
Okay.
So you don't mix that together.
Yeah.
In fact, so gallon challenge of milk used to be a common thing that would happen at camps across the nation. And every year we get reports about, hey, counselors thought this was funny. It ended up not being funny. So if it were me, it would be a carton of milk at each lap.
Like a school carton.
Yeah.
School carton. Okay? Can't do like a pint. Cannot consume, say, you got to consume a whole gallon by that time. Okay? And 99% of the time, people will just throw up. It'll be too much lactose in them. They'll just throw up. They'll be fine.
But that 1% of the time.
Yeah, you don't want to.
And
You don't want to be that. Okay.
Yeah.
Yeah, exactly. Then you got to think about just general conditioning and in general. So we actually had kids and they went to the gallon challenge of water. You see, who can slam down a gallon of water in 5 minutes? They actually have recorded deaths from that as well.
Because you drown yourself.
Yeah, it's incredible to think about. It's like, well, I don't think it can happen. It's just water. But so you've got to be careful with consumption.
Okay.
Yeah.
Okay. We're weighing the risks here because we got to get a fantasy football punishment.
Yeah. No. So what I would just say is that I would say carton of milk at every corner, and you can only pause like once on each lap or something like that. So you got to just keep moving.
Yeah, because our original one was a 1v9 firing squad paintball.
Okay.
And we thought that was too cruel, so we went to this, and now I've realized that there's death involved, so that might also be too cruel.
I don't want to overreact. I'm just saying, you got to be careful with the.
Yeah.
So.
I guess we didn't really think about that.
Alrighty.
Again, chances are slim, but okay. In your homework, I want you to open up to the section that talks about this. Okay, coterminal angles. So you're probably going to turn. I think it's back in your homework.
Is it homework or a note?
This is in your homework. This is homework, not your notes.
Oh, I was wondering.
You turn in your homework. We're just going to talk about this one-page thing. It's something that we just didn't get time before. I know I mentioned this earlier, but again, it's it's just learning to do with the 42 minutes of class reality. That's a challenge. Everybody here at this spot?
Yes.
We're going to show you something. This is going to be quite easy. Actually, tomorrow's lesson is pretty easy as well. Got a couple easy ones here. And then Thursday's lesson, it's actually going to take us 2 days to do. It's a little bit more involved, but we're going to give you a good amount of time on Friday to work on it. And then Tuesday's just a really fun day. It's SOHCAHTOA. So, so you're kind of this whole like unit circle thing. You're kind of almost a little bit past that. You guys are really mastering some of those pieces. Okay, so good for you. So coterminal angles. What is a coterminal angle? Is just something that comes up in trig. We're going to use it from time to time. Angles whose terminal sides are in the same position. So thought that this worked well in the other hour, so I'm going to use it again. We're going to pick 90 degrees. 90 degrees is a really common angle, okay? Can anybody think of another angle measure that puts you in this same spot, right here?
Negative 270 degrees.
Good, negative 270. Anybody think of a different angle that puts you in that same spot?
450.
450, good. So let's think about what Brecken and Axel and Nevaeh were thinking about. It looks like for the 90, looks like you went back 360 units, right? And it looks like for the 450, you went forward 360 units, right? If we want to find another one, you could just continue to add 360 onto that, couldn't you? So you get like, let's see, that'd be 810, right? And if you went back, you could subtract another 360 off of that, get like, what is that, negative 630 degrees? Like there's actually an infinite number of coterminal angles that are positive, and there's an infinite number of coterminals that are, or angles that are coterminal that are negative, right? So we just want you to find one of each today. We want to find you a positive one and negative one for each one, okay? Just one, but there are an infinite number of representations. So we'll just show you kind of the diagram of it. If you have any angle, we'll call this angle, say, 120 degrees. And again, when we draw an angle, we draw it in that location. We can draw another angle that's coterminal, that's positive. So I always just, we know it's going to end up in the same spot, right? If you're like, how do you draw? You don't even know what the measurement is yet. Well, you know it's going to end up in the same spot. It's just that instead of going around to this spot, we go around once and then get to that spot. So to find that, I'm just going to take 120 and I'm going to add 360 to it, and I get 480 degrees. So 480 degree angle is coterminal with a 120 degree angle. Simple enough?
Yes.
If we do the negative one, we're going to have the exact same location again. Again, I don't need to know what the angle measurement is. I know that it makes that shape because they're all coterminal. They end in the same spot. And instead of going that direction, I'm going to go that direction. So I have 120. Instead of adding 360, I subtract 360. I get negative 240 degrees. So for your assignment, you're going to be adding and subtracting those 360, draw them its location to see what the coterminal one is. You don't have to draw the original, but do draw two of them for each one. I want to see two of them. If it's expressed in radians, I want your final answer expressed in radians as well. And some people they end up converting back and forth. I don't like to do that too much. I'll just do one example so you guys can see how this goes, but just for reference, we make sure we get this in the right location. 5 pi over 4 is how many degrees? 5 slices of pizza brings us to?
225.
225, okay? So that's my 5 pi over 4. So if I do one that's positive and one that's negative, I'm going to go around more than once. So we're going to take 5 pi over 4. And what do we add to that?
8 pi over 4.
Why 8 pi over 4?
That's 360 degrees.
So we add 360. 360 is the same as 2 pi. And if we convert it to a fraction of fourths, 2 pi is 8 pi over 4. So I get 8 pi over 4. And I get 13 pi over 4. So 13 pi over 4 is coterminal with 5 pi over 4. And once you've done that, the next one's really easy. You have 5 pi over 4, but instead of adding 8 pi over 4, you just subtract 5 pi over 4, or 8 pi over 4. What's 5 pi over 4 minus 8 pi over 4?
Negative 3 pi.
Negative 3 pi over 4. And hopefully that starts to connect with you. You say, oh yeah, negative 135 degrees is coterminal with 225, but you don't have to do the conversion every time. You can just simply convert it to, terms of pi and go from there. Good. So you guys can continue to work on that. That's all you have for today. So just those pieces. Just want to finish up some holes in your assignment here and there and make sure that we're understanding good to go. We are paced correctly, so next week, Friday, we will get that test in.
Quiz tomorrow.
Quiz tomorrow. What? Conversion of degrees to radians. 150 degrees, 5 pi over 6, right? You guys need practice at the end of the class, or you're good to go?
Are you just gonna give us like the degree?
Yeah.
Okay, that's what I thought.
Tomorrow. Yeah. Oh, sorry.
Yep, you guys are gone. Yep.
Yeah, can we take it during 8th hour?
Yeah, that's fine. Yeah, come find me.